What's up, Datawranglers? We are going to discuss about machine learning, and I'm not the only one going to be performing machine learning on data, but the artificial intelligence about it. And if you are an early stage startup and looking for some opportunities to explore the machine learning capabilities in an automated fashion, this video will be very helpful to you. So let's dive right in. We are about to explore AutoAI. It's a service provided by the IBM cloud. So, startups and tech industries, they are mostly in search of bringing ML capabilities to their data. So that could actually drive productivity and also automate the mundane processes that the data scientists face from day to day, right? So if you could see, like the data scientists, like 80% of the data scientists' time is actually spent on feature engineering and model selection. So Auto AI is a tool that bridges the skill gaps, and also it increases the repeatability, and it lowers down the human intervention. Also, if you consider the productivity, it also increases the data scientist productivity by automatically performing all the model selections and feature engineering. It's completely like a one-click deployment um, platform. So it's easier for you to deploy your models in the form of APIs and so on. So for this analysis, we'll be looking at a diabetes dataset. This diabetes dataset can be downloaded from the link that I've given in the description below. So let's get started. Now let's have a closer look at the dataset. Right? So this is a diabetes dataset, and it has many features. Like it has about 7 features, and it has about 768 observations. And the motive of this dataset is to it gives the overall view whether the person has diabetes or not. So that during our prediction, we can give all these features as input, and we can predict whether the person is going to contract diabetes or not. So if you consider the features, you have the number of pregnancies, what's the glucose level, the blood pressure level, the skin thickness, the insulin levels, the BMI, and the diabetes predictive function, which is like they check for the generation of the people, whether their fathers or forefathers had contracted diabetes, and you also have the age, and finally the outcome, which is like a Boolean value here, whether the person has diabetes or not. So 1 corresponds to the person has diabetes, and 0 corresponds to the person who doesn't have diabetes. Now that our dataset is downloaded and ready to use, let's head out to cloud.ibm.com and try building the AutoAI model. Now I'm going to use a free account over here. You can get your very own free account from cloud.ibm.com. I have also listed the name of the video down in the description below. Now let's head over to cloud.ibm.com and let's get started. So we fire up the browser and we go to cloud.ibm.com. I've given my username and password over there. Once we log in. We are inside the IBM portal, and inside the portal we go for the Watson Studio. Now Watson Studio is the place where we build the machine learning models and can make the visualizations, and we can also explore your data over there. Now we head over to Watson Studio. we create a new project over there. So this project contains all our data, and it holds all the machine learning models over there. So when our project gets created, it comes along with an object storage service. And if this object storage is not present, you need to create this service separately and attach that service to the corresponding project. This object storage is where all the model related files and the datasets are being stored. Now it's time to add our asset, the AutoAI experiment asset, to the project. So this asset is going to perform the ML related calculations and the model predictions for us. So let's go ahead and add this particular asset to the project. The AutoAI asset needs a computation power. It needs a computation service instance for the models to run and also the training to happen, right? So we need to add a machine learning service instance to the corresponding AutoAI asset. So here's how you do that. So for the free plan, we get a light instance, and this should be okay for performing all the light computations on the data. And if you need more horsepower, you can go for the paid service instances, and these are a lot cheaper than the other competitors like AWS and Azure. IBM Cloud is a lot more cheaper in that particular case. So you can opt for a better horsepower or a better computation power um, for a machine learning instance from here. And now we need to associate the created service instance with the AutoAI asset. And here's how you do that. Now that our AutoAI asset is completely ready, it's now time to add our data source to the asset. So we browse to the corresponding location of the dataset, and we upload our directories.csv dataset to the AutoAI asset. So upon successful uploading of the file, we need to determine which column needs to be predicted by the AutoAI. So in our case, the outcome is the column which we are about to predict using the AutoAI. So we point this particular column as the corresponding column to be predicted. As you can see, the AutoAI has chosen that the binary classification will be the perfect classification model for this particular dataset. Apart from these predefined settings that AutoAI has chosen, the user can also choose their own settings and parameters for the AutoAI experiment. Now we can also define how many algorithms that AutoAI can apply on top of our dataset. And based on the number of algorithms that we choose, AutoAI will correspondingly generate all those pipelines. So for example, if you choose about 3 algorithms in this particular case, 3 multiplied by 4, that gives about 12 pipelines generated by the AutoAI experiment. Now it's amazing how fast AutoAI performs all these computations and model trials. So basically, the in data science, the whole process involves data cleansing, feature engineering, model selection, parameter optimization, model validation, deployment, monitoring, and improvement. So AutoAI takes a part of this. It's much more of like takes feature engineering, model selection, and parameter optimization, and it breaks down the job of data scientists. Like it actually minimizes the major load on the data scientists, where most of the time is being spent on the feature engineering and the model selection. And AutoAI actually fast tracks this particular these scenarios, right? And apart from that, it takes care of all the time that they spend on choosing the models, like all the trials and errors that they make. Automates all these stuff, and there's like an AI involved in correcting the machine learning part, right? And based on the model accuracy, it chooses those top ranking models, and the data scientists can simply download these models and run their model notebooks, or they can simply deploy their own APIs in order to predict the outcomes, right? And imagine what a data scientist could achieve with a tool like this, right? Uh, all those time that they can save in building in performing the feature engineering, and performing all those trial and errors, they can constructively use that time for some other better activities, right? So this has actually reduced the time from several weeks of the data scientist efforts to several minutes. So in this particular case, what we are running, it comes approximately close to 2 or 3 minutes top. Yeah. As you can see, by the end of each and every pipeline, AutoAI chooses one of the models to be best performing, right? And in our particular case, it has chosen the logistic regression to be the best performant amongst all the rest of the models. And next comes SGBM classifier and so on. But it's all up to the data scientist to choose the correct model, that the model which gives a hunch to the human instinct, like it's performing very well. He or she can choose this corresponding model, and they can save this to a file or transfer this to a notebook, or even use this particular model to make the prediction in the form of an API. So for today's video, we are going to export the model, and we're about to create an API out of it. And again, this is going to be a one-hit deployment again. It's not going to be like we are posting a separate API for this, but IBM gives it out of the box. And we are about to see how this can be made. If we wish to deploy our model as an API, we need to promote the model to the deployment space. So here's how we do that. So we click on the promote to deployment space button. This actually promotes the model to the deployment space so that an API can be made on top of it. So we don't currently have a target space right now. So we are able to create the target space under the deployments service. So we go to the spaces and we create a new deployment space. We give a name to it. Then we create the deployment space. Now we need to make sure that the deployment space resides on the machine learning instance that we get created, right? So we define that, and the space is created on top of the corresponding machine learning instance. Now we click on the promote button. Now our machine learning service has the corresponding model as an API on top of it. Let's create our API service now. Now when we click on the deploy button, it takes us to the deployment page where we can define It's going to be an online API or whether it's going to be a batch process. So we are able to create an online API which is more like a request response kind of an API. It's not like a batch process. Now it's still in progress. Within a few seconds, the API will be ready to serve. So now we are all set. Now it's time to test our very own API. Of course, there are different ways to test our API, and now we are about to follow the easiest route. IBM provides its own client over here, which we'll be using to test our API and the model. So we choose two of the rows from our dataset, and we are about to compare the performance of our model with the existing data. And fingers crossed, the outcome should be the same as what we see on the Excel sheet over here. And it's not a necessity to give the outcome of the model, because that's the one that's about to be predicted, and it's not a necessity to provide that as an input for the API. So we can omit that. Whereas the rest of the API related inputs can be provided. It worked. So we were expecting 0 as the outcome, and our model has given the response as 0 as expected. Now let's try with some other inputs over here.
Pipelines deduced by the AutoAI can also be saved as a notebook rather than what's a machine learning model. Here's how you save it as a notebook. So you define a name, then you click on create to create a notebook. Once the notebook has been created, it can be viewed in the project. It contains all the programmatic changes that AutoAI has made, or the algorithms that it has used for the corresponding pipeline. Now here we can define our own code for model deployment. Now I have added an extra bit of code for the deployment of the machine learning model that we have created. Now we are about to create an API key in order to perform the deployment. So we head over to IBM Cloud. So once when we get to the Cloud console, we reach for on the managed drop down, and we get to the access IAM. So we are about to create an API key for our notebook to create a deployment. So we create an API key, we assign a name to it. We download the API key. We're about to copy this API key onto the notebook. I will leave the link to the code in the description below so that it will be easier for you to pick it up to your notebook. Now we have our URL already. So this URL corresponds to the deployment URL, which is under the experiment metadata. So now we are ready to create the deployment. Remember the time when we created the target space for all our deployments? So now we are about to go to that particular target space and copy the target space ID. In order to copy that, you can fetch the corresponding target space ID from the URL. Just copy the target space ID from the URL and paste it onto the code. Now the created model name is changed in the code. And we also assign a pipeline name so that this corresponding deployment will be created inside the target space. As you can see, the service is getting created, and then we can use this service in order to predict. Now that our model has been deployed to the target space, it's time for us to test the model using the subset of the data. And use tasks. So using the model predicted by AutoAI and the deployment endpoints that we have created, here's a web app that has been created locally in order to predict the outcomes of the diabetes based on these features. So I'm entering the values for the corresponding features like pregnancies, glucose, blood pressure, skin thickness, and so on. And we are about to predict the outcome. So behind the scenes, we have a model deployed already in the target space. So upon click of the button, the API runs the model and fetches the results for us. As you can see, for these inputs, we get the outcome as negative. Let's try another input. Again, it turns out to be negative. Now let's try out for a positive outcome, as in whether the patient is susceptible to diabetes. And that's how easy IBM AutoAI is. Right from the model building to the model deployment in the form of API, it's really very easy.
It's really amazing to watch AutoAI work, and IBM has done a very good job in building this particular module for IBM Cloud, and I can only imagine how it will be far more beneficial for the data scientist in their day-to-day activities, and how it can accelerate the model building from weeks to just a few minutes, right? It's really amazing, and so I'm really looking forward to multiple other ways, and how they can improve the accuracy. And overall, it's I would say like the performance is really amazing compared to the manual model building. So when it's close enough, and it's like far more better, I would say, in terms of prediction. And I love the fact like the one-click deployment is a lot more easier for the data scientists to deploy their models in the form of APIs. The development team can consume it as quick as they can. Possibilities are endless using this service, and I'm really looking forward to other services from IBM Cloud. And pricing of IBM Cloud helps the startups to easily adapt to this IBM cloud, and it gives a really nice opportunity for them to explore with the free tier. Freedom that you get from the free tier, it's more easier for companies to adopt to IBM cloud. And yeah, that's pretty much what we have for this episode of Datawrangler, and thanks for tuning in. Make sure that you subscribe to the channel for getting more updates related to recent technology. And ciao. Do you like what you see over here and wish to explore more? Head over to www.datawrangler.in.